Okay, for the next presentation, it is my privilege to share this presentation with Jeff Levermore on Urban Heat Island. Oh, yeah. Finished already. On Urban Heat Island in two cities, we named it. I'm going to talk a little bit about London in the next 10 minutes or so, and then Jeff is going to talk about Manchester and also some other implications for indoor air quality and so on. Usually in my introductions, the question is what is the difference between cities and countrysides, that we are all familiar, but of course it is the pollution. And the pollution could be air pollution, thermal, which is what I'm going to talk about, and noise pollution as well. And the last few months, I took this photograph about air pollution in London in April last year. So it is a problem here as well as a problem in developing economies as well, which is the photo at the bottom, which is an example that is usually used. So the thermal pollution causes, over the years, it has been classified into 6. I'm going to talk very briefly for each of them. First of all, the heat capacity and conductivity, the difference between rural and urban. In rural environments, the ground is less dense, has lower heat capacity, has an insulating layer above, but in urban areas, we use high-density materials with high heat capacity and high thermal conductivity. Solar absorptivity as well is important. Albedo or solar reflectivity varies in both rural and urban areas, usually the color of the surfaces, and I'll talk a little bit about it later. The sky factor, which reduces effectiveness of long-wave radiation for cooling in the cities. The wind speed is a major factor because the average rural wind speeds are higher than in the city. We have rougher urban surfaces which reduce wind speeds, but of course there are local variations. And also when we've got street canyons, we have got little disturbance at ground level. Energy consumption as well, which releases heat. And rural energy use is smaller compared to the energy received by the sun, but in the cities this is different. It is higher, especially during the winter. And finally, vegetation is very important. Urban areas are harder. They have less vegetation, less evaporative cooling, less shading of the ground. But also we've got parks and green areas that they can provide rural oases in the cities. So all these parameters, as we have seen this diagram, they create the phenomenon which is termed urban heat island effect, which is mainly we've got higher temperatures in the city areas, central cities, and also in suburban areas compared to areas outside the city. Through the Lucid project that we carried out a few years ago, you can see here London, and we can see the green area, the red areas that in central locations with higher surface temperature, where there is less surface temperature in outer areas. And also with the arrow there, I have put Belsize Park as in the larger picture there, which is lower temperature because of the vegetation. So We have quite a large body of work in hot climates in US, Europe, and Asia. But a few years ago, what happens in moderate climates, such in London and Manchester, it was a little bit not known. So we measured it together with my colleague Richard Watkins, who is now at Kent University. We installed, or actually he installed, all these sensors around London that we measure it for half an hour over 2 years, including 2 summers. And together with a reference station, which is not very far from Brunel University in Langley Park. And then this is the measuring station that it was mounted on lampposts around London. And this is really the graph of the analysis of all the results that shows during the day, the hours of the day, what is the difference between the reference station and central London. So it is about 3 degrees, which was the first quantification in such a scale of the phenomenon in London. And here is a little video that shows on one of the summer days the temperature distribution starting from 8 o'clock. We are 9 o'clock in the evening now. And we can see that it is changing. It is about 5, 6, and sometimes 7 degrees. We have measured a difference up to 10 degrees between central London and the reference station. And this is, of course, an image to show what is happening on a particular day. It was August in the city, and this is 2 o'clock in the morning. So then all this data we started analyzing quite a lot, and again with my colleague Giri Reganathan, we worked on looking at the different meteorological situations and weather variables. Here is just a graph that shows in the central location the difference during the night of the day before with clear sky, partial cloudy and cloudy, and of course we can see the difference as we expect when we've got high solar radiation, then the difference between city and countryside is higher. And of course, coming to energy demand by buildings, again, we've got the heating and cooling demand. And here we can see how it is varying from the reference station to central London. We've got about 22% reduction in heating load, not energy, from countryside to central London, and about 25% increase in cooling load in the buildings. And we worked over the year through funding through EPSRC in trying to develop models on how to predict and how to simulate the energy demand by buildings. And here are the different models that we have developed. One LSAT is developed at Brunel University, LODUM by Reading University, ADMS at Cambridge Science Research, and Arab Outdoor Room by Arab in predicting what is happening in urban canyons. So all these models are available, and I'm going to talk a little bit about the first model, LSAT, that we used in order to investigate the relationship between urban heat island energy use and also climate change across London from west to east, simulating a building there. And we used the UK CPO2 weather files, and then we morphed them, and only the temperatures changed and everything else was the same over London. And I'm just going a little bit of some of the results, which again, it is what we expect, but also indicates that we need location-specific climate files in order to reduce to increase energy efficiency and to reduce overheating and energy use in buildings. And this shows what happens in an office building as we move from outer London to central London, where in outer London we are okay in terms of overheating hours, but not in central London. And the same with energy. For example, for cooling load, again, higher temperatures, we need higher energy for cooling our buildings. And this shows what's happening now. It says 2000, but it is the weather files that we use for the simulation. And then in 250 with the MORT files, and again, we can see that the increase in cooling load, reduction in heating load, of course, again, higher temperature, which one can argue it's a beneficial effect at the moment in terms of energy use. What it is, I said the first point already, is that most buildings at the moment, they are not air-conditioned, so the urban heat island probably is a good effect in winter because it reduces the heat in bills. However, in the future, and because of the climate change and rising temperatures, but also expectations by people, is that probably more and more buildings will be air-conditioned, and once air-condition is introduced, then internal temperatures will be regulated at the set points, which is usually 21, 22 degrees. At present, we tolerate higher, and actually CIBSE is telling us to tolerate higher, based, of course, on scientific evidence and people's evidence. But if we go with this set point, estimations indicate that probably we will have a 5-fold increase in carbon emissions by city buildings in 2050. And of course, this needs to be set against our commitments. So what can be done is 3 points that I have put here: improve energy efficiency in buildings, which is regulated, generate heat and electricity using integrated renewables, again, move towards the nearly zero carbon buildings. Again, there is progress on that. Improve the external thermal environment, so to mitigate the urban heat island. This is not so much advanced yet. The ways that we can do it is to reduce anthropogenic heat from buildings and transport, reduce air conditioning, increase insulation, etc., reduce cars, use electric vehicles, which again, there are quite a lot of activities and incentives on that. Increase vegetation, parks, green roofs, and green walls, that we've got a couple of presentations later on that. And increase the albedo of surfaces, cool roofs and pavements, which is something that I have worked on, so I'll put a couple of slides on that. The so-called cool materials, that they work because they've got high solar reflectance and high infrared emittance, so less solar radiation is absorbed. We've got faster release of the heat, so they lower the surface temperature. So less heat penetrates into the buildings and less heat is transferred to ambient air as well. And of course, the problem is we are not talking about white surfaces everywhere, but we're talking about manipulating the properties of different colored materials in order to have higher solar reflectivity. And this is a case of a brown tile here. From 0.27, it was reduced to 0.08. Appearance is the same, but of course it has got a higher solar reflectance, maintain the same properties at the visible spectrum. Whether it works in temperate regions such as London, We have measured it here through a European project at Brunel, and actually Alkis, that he is in the audience, he has worked on this a little bit, doing measurements, and my colleague Les Guarasanken. We measure it here, and as you see, it is a situation before and after in a building here at Brunel. External temperature the same, solar radiation is the same, but the roof surface temperature has been reduced in the second graph significantly, and also the internal ceiling temperature, which implies increased thermal comfort and less heat transfer to the building. And I will finish by talking a little bit about where perhaps cool materials might work. They will work in areas that we have no heat in demand. For example, here the graph shows that they work very well in the climate of Abu Dhabi. But will they work in areas that we have got a heat in demand, like in London, but a more extreme situation like in Wuhan in China, where they've got a hot summer, but also they've got a cold winter, and we can see here that perhaps heating and cooling needs, they fight each other, which might make cool materials better or cool roofs and green roofs better. So to conclude, urban buildings use more energy than rural buildings because of the urban heat island effect. Less heating, but in balance, more energy. We have technical knowledge on how to improve energy efficiency and integrate renewables to achieve high efficient in energy buildings. But we have got less knowledge on how to improve the thermal environment in cities now and also in the future, and in particular moderate climates, as I said before, London and other climates when we've got a cold winter and hot summer, where requirements of heating might find the requirements of cooling. So thank you for your attention, and I think without any questions, we will move to Jeff, that he's going to continue on the same theme.
A lot of what I'm going to say is what Maria has very well gone through. We're just looking at Manchester, and I have to say that the person that was working with Maria early on was Richard Watkins, who's now at Kent University, and Richard was in our research team, one of the people. He didn't actually do the measurements, but he gave a lot of useful advice. We looked at Manchester, and I just put this slide up for people living around London as to where Manchester actually is. And we did the circles just to set out our system of shields. This is our radiation shield. It's not as good quality and as expensive as the one that they used at Brunel. But we made it out of flower pot stands and some mild steel. And we put these on lampposts around Greater Manchester. We didn't actually put in the grant anything to take them down, so they're still there, and I go around and download them. And I was doing it recently, and I crossed over the road in front of a nurse in the car, and I realised that they'd changed the lamppost and hadn't put our sensors. So I looked up and down this lamppost and then walked back across the road, and this nurse thought, I think he should be certified. But I know most of the lampposts in Greater Manchester now and most dogs. This is the urban heat island in London, and this has come basically from Maria's work and people at UCL. And this is actually the basis of what's in the CIBSE Guide A2, which is relatively new, came out recently, and shows the observed and the modelled, because there's very good models for London now, and because they actually pay for their sensors to be taken down. We've got a few more measurements in Manchester. And if anything, this shows why averages are bad. Because on the left-hand side, it's got the summertime temperatures in the daytime, and the winter and summer there, winter daytime. So you've got a slight urban heat island, about 1 to 1.5 degrees. but it's at night time that you get the greatest urban heat island, which means your buildings cannot cool down at night time, and people in vulnerable areas, in vulnerable people, will suffer. And I think that this is picking out these particular days here is what is required for looking at the urban heat island. And looking at the transects which come around, we can see that there's an odd one there. This is going from the city centre, Piccadilly Gardens, out towards the areas of rural parts of Greater Manchester. And there's one line there that drops down, and it's always intriguing as to why there is the exception. And this is Heaton Park, which is in North Manchester. And we can see it's got a big reservoir and a lake there and a large area of green. So this is the first message. Green and blue actually helps you reduce the urban heat island. And this is just another picture map showing Greater Manchester on a scale, showing that that is still a fairly large area within Greater Manchester. That's the ring road going round it. So with the essence of greenery, I'll quickly go through this. Green roofs are quite good. You can take a flat roof like that and put sedum and various other things on to make it into a green roof, and a lot more trees. The interesting thing is the urban heat island of Manchester is similar to that of London. But I think, being a Londoner, there are a lot more parks around London than there are in Manchester. A lot more trees. I stayed last night at Cartwright Gardens near Euston Station and St Pancras. And when I was a student there, we used to play tennis in Cartwright Gardens in the centre. And there are trees there, plane trees, very pleasant. And I think Manchester, which is a Victorian city where money was the dynamic, meant that there wasn't so many of these green areas. So what we want to do is to try and make them with more trees, even like that, to actually help the city centre. And also, if we look at this, and I think that Maria mentioned this, looking at the weather parameters, we can see that the wind speed increases and at the night time, and the urban heat island reduces. So above about 6 metres per second, there's a much reduced urban heat island. And this is the summer equivalent here, showing that dogleg. So if you open up the city, it's one of those engineering situations that narrow canyons actually shield you from direct sunlight. Whereas if you open them up, you allow the wind speed to increase and blow the hot air away, which is beautifully shown in the previous SIBSI guide from Richard's work. We also looked at a simple little building in the centre of Manchester and added on the urban heat island, very similar to the work that Maria did. And here we can see that if we look at one particular day, June 2010, we got a lot of data. And we took the actual rural area and we looked at the cooling load with the urban heat island added on, and we can see that there's a significant amount. In the middle there, we assume the air conditioning would be switched off for lunchtime, which is perhaps not too realistic. The site there is actually Woodford, which was near to Manchester Airport, which was the Met Office site. That was pretty rural. More rural perhaps than Manchester Airport. And here again we see a number of days in this month, and in some cases the cooling load is dramatically increased. So this is what it looks like actually over a number of days, and you can see that generally there is that increase in the urban heat island for the cooling load. There is a corresponding reduction for the heating load during the winter. And this is, when you add them up, what it looks like. So you've got the benefit of the reduction in the winter, and you've got the increase in the summer. But this doesn't look quite so dramatic, But there are particular days when you do get the urban heat island, it is very dramatic. And if you get 2 or 3 days together, you can get very uncomfortable situations in city centres. But the more disturbing thing is that we look back over the history of the urban heat island of Manchester. And what we find is that it is increasing quite a lot over time. This is from 1995 up to 2014, or is it 2012? And we can see that if we go over the century, there's going to be almost quite a considerable rise, a couple of degrees, 1.5 degrees to 2, added on to the urban heat island. And a lot of people assume that the urban heat island is more or less a constant. But the fact is that we seem to be building on green and grey areas, and this is our analysis. There is a paper on this, and I don't go to this in great detail. But the data is actually in the new A2, SIBSE Guide A, and I think Anastasia is here to tell you even more about it. We're probably going to be planning the next edition of it. But there's a lot of data in there. It's also got climate change data. And we've got the Manchester and London data there as well. And in fact, this is taken more or less from the A2 guide. You can see that the Manchester data for that annulus is very similar to the London urban heat island. This is the factors you have to add on. So about 3 degrees C for Manchester and London, whereas Manchester is a much smaller city in population and size than Greater London. And here's actually the urban heat island measured against the Heathrow. And so there is a certain amount of urban heat island around Heathrow. So in conclusion, the UHI in Manchester is significant. And it's increasing with time, and it affects cooling and heating loads, and it's in the updated SIBSE guide. Thank you.